Hi, my name is Austin DeGroat, and this is Iceland, a Geologic History. So first off, I'm going to start by explaining Iceland's geologic history and how it was created. About 100 million years ago, the volcanic plume under Iceland formed around this time. This phenomena, combined with the mid-Atlantic ridge, caused the very beginning of underwater Iceland to form. About 10 to 20 million years ago, the volcanic plume began to form Iceland. The oldest rocks on Iceland are around 16 million years ago. So around this time, it started to begin to come out of the ocean's surface. And we can tell this because of the age of the rocks. So the oldest rocks on the outside of Iceland are roughly 16 million years old. So that would be about when we can guess that Iceland began to come out of the sea. And around 3 million years ago, during the Ice Age, all valleys and fjords were created in Iceland due to the erosion of glaciers. And this is around the same period as the Ice Age. And during the Ice Age, they experienced a lot of warming periods as well. And this can be attributed to why the valleys and fjords were created due to the erosion of the glaciers. Iceland, geologic creation mechanisms. As stated in the previous slide, volcanic plumes formed under where present-day Iceland is located. When this happened, a hotspot formed above the plume. These hotspots generate magma that rises through the lithosphere, producing active volcanoes at the surface. Iceland's hotspot, as shown in the diagram right here, is along the mid-Atlantic ridge. This constant volcanic activity played a major role in the creation of Iceland, as lava hardened, creating land. And this diagram kind of shows where the focus of the plume is. It's this little yellow circle. I'm not sure if you can see it in the video, but that's where the focus of the plume is. And the mid-Atlantic ridge goes right through that red zone right there where the rift zones are. And as you can see from this diagram, this kind of explains why the oldest rocks would be in the outside, because it grows from the inside out. Geologic creation mechanisms, the second one. Iceland is situated right along an area where two pieces of earth crust are constantly shifting. This area is known as the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is an area where, as the diagram shows over here, the North American plate and the Eurasian plate are separating. Magma from the Earth's mantle makes its way upward, at which point it erupts from the seafloor. The lava then hardens and turns into new crust on top of the separating plates. Due to this, Iceland slowly grew into the large piece of land it is today. And this diagram kind of shows over here the North American plate on this side, the Eurasian plate on this side, and the separating of the two. Now the lava from the mantle would seep upwards once these two plates separate, creating the little islands over here, which would eventually form into Iceland. And this diagram is another representation of the plates separating. It also shows some of the volcanoes and where they're located on the island. As you can see from this diagram, Iceland actually grew from the inside out, as stated in the previous slide. Now, the Mid-Atlantic Ridge is this pink line that runs through the middle of Iceland. And as you can see, I don't know if you can see this or not, but the little red triangles in the diagram are where the volcanoes are located, and almost all of them are located in the middle of the Mid-Atlantic Ridge. Iceland's general mineral composition is essentially mostly composed of one kind, and that's olivine basalt. Basalt is a hardened volcanic rock formed when lava cools and turns into crust. It contains four minerals: plagioclase, augite, olivine, and magnetite. And this is kind of what basalt looks like. And as you can tell from the constant volcanic activity on Iceland, this would be the reason why it's all composed of this. Or mostly composed of this, I should say. Iceland's present location, it's positioned between Europe and Greenland, about 200 miles to the southeast of Greenland. The Denmark Strait is actually the body of water that separates the two masses. And this picture over here kind of shows that. The little red highlighted is Iceland, and to the left of it, or the southeast, or the northeast actually, is Greenland, and Europe is down over here. And the Denmark Strait would be the body of water that's positioned in between. Iceland's 3,000-mile coastline meets many other bodies of water as well. The Greenland Sea on the north, the Norwegian Sea on the east, and the Atlantic Ocean on the south and west. And this diagram kind of points out the bodies of water. Iceland's current situation, it's one of the only bodies of land that's not drifting with the rest of the continents. And this can be attributed to the hotspot under that lifts it from the sea. The forces that once created Iceland are still working on it today, causing it to grow in the height at a rate of 30 millimeters per year. This rate of growth has been steadily increasing each year. Scientists think that this increased rate of growth can be attributed to the melting of Iceland's glaciers. This is potentially dangerous for inhabitants because the melting of the ice has a direct link to the frequency of volcanic eruptions. The future of Iceland is kind of a volatile one, filled with earthquakes, volcanic eruptions, and geysers. This causes some areas to be almost inhabitable. The two divergent plates continue to separate Iceland and form new crust in between. This phenomena constantly expands Iceland, making it larger every year. The scariest part of Iceland's future is that if and when the Icelandic hotspot dies, Iceland will die with it. It is possible that if this occurs, Iceland could sink and disappear into the water forever. And this could kind of be attributed to global warming and the melting of the glaciers, and the no more growth of Iceland would make much of it sink. All right, thank you for watching.